Welcome. Thank you very much for attending the webinar. Today, we're talking about 10 Fusion 360 tips and tricks. My name is Ajay. I am the technical specialist in the manufacturing and process plant environment at Baker Baines. On today's agenda, we will have a quick introduction as to what Fusion is, who we are, what we do. Then we'll move on into the 10 tips and tricks: conceptual design, modeling, collaboration, simulation, drawings, and manufacturing. So all of those are the different steps in the design process. And we will be talking about a few little things that you may already know, you may not know, or maybe just a reminder for those of you who already have a fair amount of experience in Fusion 360. And then at the end of which, we will talk a little bit about what we can do. In introduction, already mentioned, my name is Ajay. I am a mechanical engineer with experience in design, manufacturing, a little bit of project engineering, installation management, as well as I have a qualification in lean manufacturing and quality management. So moving on quickly, what do we do at Baker Baines? Our solutions include consulting, education, software, and hardware. When it comes to consulting, we assist with project workflows, projects themselves, assist with CAD/CAM, data management, a little bit of BIM consulting. And in the education space, we do have accredited classroom and virtual training, also provide a platform for self-paced e-learning. You will find us mostly in the building, energy, manufacturing, process, plant, and civil spaces. First and foremost, let's just talk a little bit about what Fusion 360 is exactly and what it can do as the entire workflow process or the design to manufacturing process. What Fusion 360 is not just a CAD program, it's not just a CAM program, it is an overall. It has aspects that you can use throughout the process of design, conceptual modeling, all the way through to manufacturing of your product, and then bringing it out to market as well, with everything in between. It connects your entire product development process at every phase, from product definition through engineering, production engineering, all the way to shop floor production. It can be used by a variety of different people. I mean, you can try and use all of the functionality individually if you like. Versatile to the point where a large number of different people in the process can benefit from it. Fusion 360 comes with a number of extensions that actually extends the workflow capabilities of Fusion 360, in addition to the core product capabilities that it has. So in the design space, you've got the product design, the generative design, and simulation extensions that allow you to sort of streamline your production and design process, where then you've got the manufacturing extensions that give you the additive build options. So that's more for the 3D printing and additive manufacturing process. And you've got your nesting and fabrication and machining extensions that further extend the capabilities of Fusion. So the machining extension takes it to more multi-axis machining beyond your 2.5, 3-axis machining as well. Then you've got the data process and data management side of Fusion 360, which comes through Fusion Manage, which is a sort of a data and document management process that allows you to go through your design lifecycle as well as managing your documentation for it. First, we'll talk a little bit about the concept design part of Fusion. So there's a couple of things that I want to talk about that will assist you with your design process in Fusion. So the concept design is usually the first part of your design process. You usually come up with an idea for a solution to a potential problem, potentially just an addition to something that you already have in place. So the first thing that we're going to talk about is your sketching tools and the constraints. So as we all know as designers, step one of a design comes with a sketch. It could be a freehand sketch, which then needs to be translated into your software. And the next thing we're going to talk about in the Fusion 360 environment is a primitive solid. So initially, the first thing that we're going to talk about, as we said, is the sketch tool, right? Now, as we know, there's a model history in the bottom here, and we've got a breakdown of all the parts and things that are involved in this model on the left-hand side right here in this tree. So in this sketch, I'm going to go into the edit sketch. If you just double click on it, you'll see now at this point in time, you notice that the entire outline of this frankly odd sketch here is black. The reason it's black is that it's currently fully constrained. Now to constrain a sketch is to make sure that you actually make sure that it cannot be modified by mistake, unintentionally, expecting to do so. Because if, let's say, for example, if I had to actually remove one of these dimensions in here, or two of these dimensions, you can see that the sketch stops becoming constrained. But as you can see, the sketch, as I move it around by clicking on the edge, it's moving around in as an entire single entity. Now, the reason for that is that it's no longer constrained to the space in which you're working or into the plane that you're working. It is now constrained to itself as a outline. And that outline has been constrained using a combination of your physical or your geometric constraints and your dimensional constraints. So if, for example, I wanted to make that a little bit smaller, I would be able to change that, and then this sketch would change accordingly. You can also over-constrain a sketch. Now, by doing that, you can actually see when you try and over-constrain it, basically what it's telling you is you've got the 100 total height, and you've got your different constraints that are actually keeping this in place. So this remains, this section over here remains in play. So what you can do is create a driven dimension. The driven dimension sits inside brackets, just as a visual. Now, if we change that again, now you'll see that the one that was set up as a driven dimension is now changing to suit the changes that we require. So that is the benefit of having everything constrained to each other, everything relative to each other being set up in such a way that you have full control over your sketch. And then it also allows you additional capabilities when it comes to parametric design. So, for example, you can actually start taking these values here and linking them via equations. So for an example, that is 1/5 of. So you can actually take that and say is equal to that one divided by 5. Parametric modeling. There we go. So when you actually set that up, you see that the fx is shown that it's actually a function of something else, and it's an equation-based thing. So every time this changes, the height of the model changes, the length of this section here will change accordingly. So if I change that to 80, that becomes 16, and so on. Now, if you want to constrain it in space, and you can see all of these little symbols are actually constraining to itself geometrically. So this line will be perpendicular to this line is vertical, this line here is horizontal, and so on. There's a lot of these things that we can work with, many of them, and it takes a little bit of practice and a little bit of time to work on it. But once you're there, it allows you a significant amount of control, along with parameterization on your equation, on your modeling. So let's put these dimensions back so that it actually sits in that sort of space. The reason I'll show you why I want to go this way. What I want to do is I want to constrain that. Let's make it 5 millimeters away. So now the entire sketch is constrained in the space as well. So if, for example, you are actually doing a rotated view of something, or something that's in relation to another part, because Fusion 360, as you know, you do multiple solids in the same space, and you can do assemblies all in one. So when you're doing that, these positional constraints and dimensional constraints start to become important with regard to your origin point, the 0, 0, the XY 0, 0 point. Just quickly, in a background, we'll give you a quick overview of the different tools that we have in Sketches, where we've got lines, rectangles, we've got circles, arc options, polygons, ellipses, slots, splines, conic curves, and points, as well as certain of the other patterning functionality that we have available to us. Those are some of the sketch tools that you can use and some of the constraints that you can use to control your sketch and parameterize your sketch. But let us finish off from here and speak about the primitive solids quickly. Now, another aspect of conceptual modeling is that we have certain basic shapes that we work off, and those basic shapes could be square, cubic, could be circular, or cylindrical, it could be a whole bunch of them. Now, what Fusion 360 allows you to do, and it gives you the option to do, is to actually set up a couple of primitive solids that you're allowed to use. So you can actually set up a primitive box. For example, here it's asking you now to draw a basic square shape. So let's make that a 50 by a 50. Now you've got a square, and then it asks you to what the height is. Let's make it also 50. So now you've got a cube. And this here is a primitive solid that allows you to simply create these different shapes without too much effort. You can, I mean, the coil and the pipe are actually quite good examples of it. And I'll show you a torus now quickly as well. If we remove that, let me quickly make up a torus for you, and we will see what. So if this is now asking for the radius of the torus, the outer radius, and then it's also asking you for the inner diameter or the ring diameter. Now the ring diameter, I'll make it 5 mils, and here you've just got yourself a ring. And here you would select the type of Boolean operation that you want. So whether to join to an existing solid, to cut through, to intersect, make a new body or a new component. So this, and then you've got your options on your torus to make it on the inside of the circle, on the outside, or on the center of the circle that you've drawn. What primitive solids can do for you is, without having to go and make a sketch for the primitive solid, you make the primitive solid, and then you take out you add your features or remove your cutouts and additional things that need to be done. Next up, we will speak quite quickly about certain tools that we have available in the modeling and collaboration part of Fusion 360. First, we'll talk a little bit about the press pull feature. Very, very nice feature in Fusion 360 that gives you a large amount of control, but also a very easy to use modeling tool. So a modification tool for your features that are already been created. So in your solids, your features, your different sections, your sizes, diameters, you name it, we'll be able to change it using the press pull tool. Then another handy tool that we have is the ribbon web tool. When you want to create gussets in whether it's a sheet metal design, whether it's a plastic outer shell design, so for example, you want to make a box or a remote control for your TV or whatever the case may be with your different gussets and different locations, it needs to strengthen a shell. And we will also be talking a little bit about the boss and snap tool, a tool that allows you to fasten two halves of a hole together. If you're talking about a shelled item like like I mentioned before, a remote control or anything like that, you need to find a way to actually put them together. Now, one of the ways in which you would do that is to actually set up a hole, create a boss, put the threads in, set up your screw, and all of those things. So that's one of the ways, one of the things that you have an option to do. The other thing is the snap fit tool. So I'll go through them very quickly with you. We will be looking at, firstly, the press pull. The press pull tool allows a lot of freedom in terms of modeling. So if you look at this candle stand lookalike objects that we've got here, if you select the face, and you can actually do this visually and using your mouse just to extend the face of the model. This extends not just to models that you've created with the intelligence that you already have, even models that have been brought in from other packages and models that come in the dumb solid type of files, you will be able to actually use this tool on. So this face has now been extended by 70 millimeters. You can control this specifically in the distance that you'd like. Let's make this 75 just for this. And what you can also do, you can see the hole that's in the middle. Now you realize that you want to change the size of that quickly. You can do that as well using the press pull tool with ease. It easily modifies the internal hole, the cylindrical size of that as well. You would also be able to, let's say, for example, extend this face a little bit along with the contour that's already in place. We can extend this face over here a little bit as well, but as you can see, it actually follows the contour of the base plate. So all of the surfaces that are attached to it will automatically be modified to suit what it is you need. Another handy tool there, and then you can also change the diameter cylindrical section just by pulling it out like that. Now, this is a very, very easy and handy to use tool, especially when you're wanting to do some, let's call it organic design, shall we? All right, so the next thing we're talking about now is the ribbon web feature. So if you look in this, I've taken the liberty of creating a couple of sketches. And when we say sketches, we're talking about just simple straight lines along planes and such. Now, if we want to use the rib tool, you go to create, you go into the rib. What's actually very cool about this is that you can actually draw a sketch, and I'll show you what this particular sketch was drawn like by just editing the sketch. As you can see, we've drawn it along a plane along that on that section of the part, and you'll notice that when we actually go and do a rib, you just select the line and then you select the thickness of your gusset, and it automatically creates it to the next available feature. Well, in this particular instance, the bottom of the shelled box. You can flip it around if you like. You can change the direction or the position of the gusset itself, or you can actually flip the direction of the gusset as well. Make it look like that. And here you can start adding offsets and such as well. But we're going to go back to where we were, and this is essentially what a rib tool does. Now, the web tool, also very, very powerful. You can actually create a web like so, and it's also creating a gusset. We also need to specify the thickness of the section. Now you see that it's actually following your sketch to the T, all the way to the next face. And again, you can specify the extent type. If you say distance, we make it 10, it'll become just a section on the top over there, for example. Up to a point, you can also angle these you can a draft angle. So let's create a draft of that nature, and we can also do something that looks like that. So if we want to create a draft angle, we just make it, you can also pick an angle, make it 45 degrees. And this allows you to create something like that, if that's what you are so inclined. So let's go with 0-degree draft angle, and let's go and flip it back in the correct direction. That is the web tool. Let's go to next, back to the next available feature. Another thing that you can do with web is very interesting, very cool, is if you hit the web and you look at that little section over there, you can make any shaped gusset web or with any form of thickness. I mean, obviously within physical limitations, gussets like that as well. So you can go and make any form of profile and create a gusset, a web, or a rib on the inside of your tool in that way. So between the two tools, you've got a large list of options and capabilities that the software has to suit the design intent that you may have. Interestingly, you'll also notice that I've created a small short little crossover there that you'll see what it does is when you click on web there and you then specify the thickness again, see that it actually takes it along that line up to the next nearest features. But however, you'll also notice that if once you used it, the sketch is consumed. So let's actually open up the sketch again or make it visible again. And we use the web tool again over there, make it one. It takes it to the next feature that reaches the extent of the web or the height, the plane where the web has been created. So whichever feature actually reaches that plane, it will go up to the next point there. Or you can specify a distance for it. If we go with 10, it's a thickness of 10, and off we go. So it takes it to the next available section. Okay. So this is very nice feature for everybody to use, and when you want to use a gusset, a stiffener, any form of strengthening planes, this is an easy to use tool that anybody can use. So we're talking about we spoke a little bit about the bosses and the snap tools that are available. Now the boss tool, I mean, you know from experience that you would create a raised surface with a draft angle and then drill a hole through it, putting all of those together, you would, to be able to put all of those together, you would then go and create a boss. And a boss, all it needs, we need to assign a plastic rule, of course, and all we need for a boss to work is select that. Let's go with the nylon, right? Okay, select the component to the whole thing. And now that we've actually decided what plastic that we're making it out of, and then we select our boss tool. Now, all you need here is a dot or a point on which you want to specify your boss tool. So what that does is it automatically modifies your design to suit a fastening process or a boss process. And then from here, you've got a large list of options that you can select from. So you can even add ribs while we're at it. But here we've got the points that we've selected, the offset position if there is any, the type of screw head we want to use, the type of screwdriver that we're going to use, the type of thread form, the thread angle, the thread diameters, and the length of your screw is automatically selected depending on what you've got, or depending on the profile that you want to add. And then your hole type, which is a counter bore in this particular instance, and the step type that you're going to have. So you can have a step in there as well, but I'm going to go with none, make it easier. Then we've got a few advanced options that we can work on. Now, with the advanced features or advanced tools that you've got, you can specify certain height thicknesses of the different aspects of your boss design. So whether the height of your top, the width of your hole center, so on, can all be specified by yourselves. If we just click on OK, you'll notice there's a couple of things that will happen. So you will now notice that first and foremost, there's a constraint in play there. Two of these are actually now constrained to each other. And you'll also notice that there are additional parts that have come in. These are purchase parts. These are the screws that would go into your boss. They are automatically generated and automatically populated into your fastening. You'll see there's nothing from the bottom, but what I'm going to do now is to actually try and move, just to show you, I'm going to try and move the top piece. Nope, cannot do that. Why? Because the constraint has been put in place. So now what I want to do is I want to move copy that top section, and I move it up, and just to show you what it looks like underneath. Remember, the constraint stays in place, so when you move it, this is just for visual purposes only. Okay, so there's your screw that's shown in there. There's the top of your boss from the bottom section, and there's the boss from the top section, or at least the slot through which your screw will go. Cancel that, put the item back. Now, this is a very, very handy tool, I find. And then the next thing we're going to talk about quickly, we're going to use the same model for this, is the snap tool. So again, it comes down to the same thing. Another fastening type is, if you don't want to have the screws and the bosses and all of these additional odd features that come out, they're like small and finicky to work with, you can add a snapping tool or snap fit tool. Again, we come down to the same type of thing where we need just a point. And the issue with this one is that you can rotate it to suit your part, right? So if, for example, now you want to look at it like that, okay, so yeah, that's fine. Then you start flipping, so you can rotate the direction of it. And then if you look at it from the top, you can see there's an angle selection tool that you can make. So you just select the direction you want it to go. So in this case, you want it to go, what is it, 270. Make it 270, it faces your part. Now, if you flip it over, you'll also note that you need to actually select a tool. So you'll see that it says no target body found. So you need to actually select the target body to which it is actually being connected. Let's just flip it back, and then you'll see that it's, now you can see what it does here is it automatically creates the snap as well as the slot for the snapping point. Okay, there, we'll see what it does. When it's finished, it looks like that. So what it does is it actually goes onto your surface, connects to this part as a single, and then it also creates the slot for the snap, the snapping tool. So if you go to the snap fit again, well, let's do some editing here. You can specify your length of the leverage. You can specify the thickness of it, specify the angle, the actual snapping on the profile over here. You can change a whole other bunch of things. So I'm going to do one more snap quickly just to show us what's going on and how it works. But again, our sketches need to be visible for this. So let's do another snap fit. Select our point. And again, I'm going to deselect all of the other points. Here you can see it's been set up now. What you can also do is you can change the type of snap that you've got, that you can actually change it so that it actually slots like that. There are a multitude of different options that you've got. So if I just click on OK, you'll see what this looks like. And most of us have seen or worked with a fastening methodology that looks like this. The next thing we're going to talk about, and we'll move on, is the Fusion team. The Fusion team is a wonderful collaboration tool which allows you to collaborate with people no matter what your physical distance is, where you are. You're able to connect via the cloud. I'll just quickly show you. If you quickly go in your project and you open it on the web, what it does is it opens up the entire project online on a browser. So what this is basically, it shows you all of the parts and all of the models that are in your project, all of the members that are in your team. You can invite people as an editor or just as a viewer, just so that the people can see it and comment. And you've got the wiki pages that you can add to certain items, like your parts that may be purchased, that you can actually have a look at. Things that you can upload from a file folder. You can create a new folder. All of this stuff is being held in the cloud. Also, remember one other thing about Fusion is that everything that you work off is in the cloud. The new one folder that's been created there, just for any form of collaboration that you may have. All the activity that's happening in your project, that has happened in your project and is happening in your project, can be viewed via the project activity section. We'll speak a little bit about simulation. We've got a static stress simulation capability that Fusion 360, the core package, actually comes with, as well as a laundry list of other simulation methods that you've got, or mechanisms that you have. So static stress, model frequencies, injection molding, even for bringing us back to the plastic tool that we were speaking about just now. We can actually simulate how the injection molding for that plastic part will work as well. However, that comes in with your simulation extension. The static stress comes with your basic. There's a few of them that comes with the basic, and then there are a few that comes with your simulation extensions. Simulations are necessary, especially when you want to actually see what your product will behave like in real life, in terms of how it would handle stresses, strains, and loads, as well as thermal. So we'll quickly do a static stress simulation. I have taken the liberty of already setting up a previous model with your constraints. So here we've got two rigid body constraints on both ends of this I-beam, and then we've also got a pressure force over here. So we're talking about loads here. You've got structural loads, linear, global, and so on. So if you go structural loads, you'll also see that the types of loads that you have available are, you've got your forces, pressures, moments, bearing loads, and then you specify the position of the thing, as well as your location and the face upon which it's happening. You can, and in some cases it is necessary for you to toggle on gravity or toggle it off. So here you can see here on the load cases that we've specified gravity and one specific pressure that's happening in the middle over there, along with your constraints types. And once you've actually set this up, you can actually simulate the results. And once you got the results, you've got a large list of options where you're able to what things that you can see. So here, what we've got in this particular load case is that at this section, we're looking at the safety factor and at what point on the beam safety factor is available. Now you can look at the different stresses as well, and that's shown here on the von Mises type or on any one of these other variances. And then you can check your stress within at any of these units. You can also look at displacement. Now you'll see if that specific load has been applied and with the specific material that's been set up, this is what the center point will deflect by that amount. So you'll see you can actually go and just highlight the sections that you want to look at and define how you want to actually look at the regio stress diagram. So for example, you see that there's a max stress of 1675 MPa. If we drop it down, you can see that none of the points actually reach that. So as we go down, you'll start seeing that which section of the I-beam is experiencing what stress level, and you can go the other way as well from the bottom up. So if you take it out like that, you can see what part is experiencing what level of stress, and you can strengthen, fasten, maybe add your gussets and your ribs to it to strengthen your part that under these circumstances. This allows you for a lot of design capabilities flexibility in the design that you have. So I mean, use the stress tool to actually change your design. You can even strengthen or weaken certain areas. Now you look at like your minimum section, like over here, you've got like very little stress. In this case, I've obviously gone with a very big force, so that will not be worthwhile. But I mean, if the force is a little bit less than your maximum forces as you've calculated is less, you'll be able to then check which sections you can actually remove material from without losing too much out. Next, we're going to talk a little bit about drawing and the drawing environment in Fusion 360. The drawing environment in Fusion 360 very easy to actually get to. Whatever part you've designed, this actually does look a bit odd, yes, but this is a multi-body, multi-component assembly bug that I've created with a bunch of random little holes and things. What you will do is you will change your design space to drawing, and from drawing you move to from design or from animation. So if you've got an animation in play, like you can have an exploded view or an animated or a snapshot from an animation that can be used in a drawing. But I'm going to take it from design. What it does, you can specify what sections or what parts you want to have in your drawing, what do you want to do with the drawing, which template you want to use. If you have a template that's been set up, you can browse for it and pick it up. What standards, units, and sheet size. Okay, so when you say okay, Fusion 360 creates a brand new drawing environment with your base view that's already automatically available to you, or alternatively, you can go there and select base view. Now, while you've got the base view, you can see that it's actually scaling it, but now you'll see in this instance, the part file itself or the image is very small. So let's change that scale a little bit. So when you're placing it, you've got a whole bunch of options, whether you can select which orientation you want to look at, how you want to look at it, whether it's visible edges only, visible and hidden, shaded or not shaded. Also, you can add automated center lines and such. Well, and you can show which edges are made to be visible. Again, what is being represented here. And here you go to a projected view, you select the base view, and you start projecting the views. So you can go individually to different views and actually change the way the view is being shown. So for example, we can make this the three-dimensional or the isometric view to look like a solid. It is useful to show what the part would look like in solid. Again, you've got auxiliary view creations, section views. You can just actually select the tool, the side you want, and then when you right click and say continue, it gives you a section view of the part along that line. So okay, there you go. Again, you can go a break view, you've got sketch views, modification tools, geometric annotations that you can add, dimensional annotations, text leaders, notes that you're able to use, symbols, symbol types for like surface finishing, and all symbols that you're able to actually specify for manufacturing. Pictures can be inserted, tables of all kinds, and you're also able to export to PDFs, DWGs, DXF, and CSV format. Now, if you've got something that's being done in Fusion and somebody's got Inventor or AutoCAD or one of those, you're able to actually then export it to a PDF or a DWG for that, and then a PDF for a layperson to view as well. Next up, we will talk about a couple of tools that are in the manufacturing space, the manufacturing side of things. One of the very interesting tools, and this also comes with the machining extension, is the hole recognition tool. I'll show you what it is just now. And then the next thing we're going to talk about is the post processes and the libraries that we also have in Fusion 360. So what I've done here is I've created a previous setup already with a blank and everything. But what we are going to show here is, as you can see here, there's 3 different sized holes here. You've got a slightly smaller one, medium-ish size, and a large hole in there. So if you use the hole recognition tool, go under the drilling section, you go to hole recognition, you've got an option list, right? So if you go to options and then you say find by diameter, when you find by diameter and you go back to hole groups, right? You say, okay, go back to the hole recognition tool, and we go to options, which is found by diameter, multi-axis machining is allowed. Let's go back to hole groups. Now you can see it's picked up a 12 millimeter, a 15 millimeter, and a 50 millimeter hole. And you can actually also see by, we select all of them, it doesn't have a thread as yet, and it also picks up that there's 23 holes, and you have the tool library that it picks it up from. And once you say okay, right, what it does is it creates a list of drilling operations automatically for you in your manufacturing section. Now you'll notice that there's a couple of spot drills and then chip breaking and your rapid out spot drills that are in there to give you that drilling operation. Now, however, you'll see that there's one of them that doesn't actually, that's giving an error. That's because it doesn't know what tool to automatically select. So you would actually go there and select a tool, one of the large list of tools that's available to you in Fusion 360. So if we go to metric hole making tool and we'll select one of them, so we can filter it how we want. So if we go to hole making, or let's go here and select drill or send spot drill, then if you go right to the bottom, you'll also see, because the other ones, you've got a boring tool, you've got tapping tools and stuff, which don't work with the normal clearance hole. So you would go and select the biggest one I've got at the moment, select that, and when you click OK, now your tool has, or your operation has now come. So this is a single command to create a list of drilling operations dependent on the size of hole. So the tool change occurs, the tool path is created, everything is done all in one. Let's quickly talk about the libraries as well that are available to us in the space. So we've got a tool library. Now, if you look at the tool library, we've got a standard tool library that's local for us, or we can go to this Fusion 360. Remember, Fusion 360, once again, is constantly online, it's cloud-based. So everything is available from the Fusion 360 library via your specific installation. Now, you've got a list of all of these tools that are available for you that you can use for whatever operation you want. If you go into your local library, you can also create a brand new tool from scratch. So you've got milling tools, hole making tools, turning, cutting, probe, holders, and depositing. So we're talking depositing, we're looking at sort of 3D printing type of stuff. But if we look at a ball end mill, now we can start looking at specifying cutters, shaft length sizes, holder types, and then the data, your speeds and your feeds, and then your post-processor definition as well. So this is a very powerful thing that you can use when you want to manufacture your parts. So with all of these tools. Now, with all of these tools, you're then able to also use your machine library, which again, you've got a local library, a linked cloud, or the global cloud-based library. Now, if you look at this, you will see that the library is well populated. It's got a large number of machines that you can use, that you can specify for your manufacturing, and that defines a lot of your CAM coding and your toolpath generation, procedure generation, all of that can be set up according to the machine that you have in play, depending on the movement of its axes or the table bed or whatever the case may be. So in here, if you go over here, you can actually see, you can set up filters for the type of machine that you're looking for. Is it capable of simulation, vendor as well? Right. Moving on, we'll also look at the template library. Now, these are preset templates on multiple operation creation. So you'll have like two or three different operations to do a hole drill and then a cleanup, so that you actually get a hole and then you extend the site. So that's a drilling operation plus a milling operation that are put together, or that could happen in a mill or a lathe. Those can be put together. Now you can add any of these presets to your own local library. If you look at this one, I've got it added. The drill and countersunk hole is a single template. Now you'll see here that you've got a plunge drill G81 command, as well as a chip breaking G73 drilling cycle that can be used in combination as a template, simplifying your process, simplifying your CAM creation as well. Then you've got a list of post processes that you can use to generate your CNC code to send it to your machine to automatically manufacture. Again, this is the one that I've recently used, but if you look at the Fusion 360 library online, all of these are available. Got everything from 5-axis works, you name it, almost it's there. Got a large list of them. You've got Autodesk ones that are standard. There's a few you can get to the Fanuc. You can get to, there's a bunch of Haas ones as well that you can use. Yeah, so there's a large list of post processes that you can use, and if you don't find it, you'll most probably also be able to find it online. And also the post processor or your cheat code that's generated by your CNC generation can also be modified to suit any specific machine that you may have. And as a little additional bonus, I have just given you the keyboard shortcuts that you are able to use. So if you'd like to take a minute to take a photo of this, I will be putting the link that you can see at the bottom left of your screen. I will be putting it in the chat box so that you can follow that link as well. We've looked at the sketching tools and their constraints, primitive solids, the press pull, ribbon, web, boss and snap, Fusion team and collaboration, the simulation capabilities of Fusion 360, how to do and the drawing environment in Fusion 360, the use of the hole recognition tool, as well as some of the post-processor and libraries. And also we've got a list of shortcut keys. So what can we do to help you guys in terms of getting going with whether it's projects, whether it's software, whether it's training? And CAD Learning being the e-learning portal, 20 minutes a day, you can learn pretty much most of the Autodesk software family. Another thing that we've got on our website at beckerbenz.com is something called transformation tools. Most of the tools are actually currently free. So, just a little bit of work assistance with your workflow. Maybe it's a tutorial video. Maybe it's, for example, we've got a couple of templates that are on transformation tools that will assist you with whether it's Revit or Inventor. So please have a look on our website, and you might find something that assists you with your workflow. And yeah, one of these tools may be useful to you. Thank you very much for attending. Thank you very much for joining us. It was my pleasure to actually present a little bit of Fusion 360 tools to you. Please find us at the 2 addresses listed on screen, and we do have quite a significant social media presence. Have a lovely day further.